Okay, so I'm going to look at part 2 this time, and we're going to focus on part 2a, the wavelength. So measure, estimate. This estimate's really important. You just kind of have to put what you're assuming. Okay, so we're going to wavelength that you measure in meters, and that's the lambda, lowercase lambda. So, okay, so we're looking at wavelengths. Just a quick thing on wavelength. It's going to be like this. Like, it's basically how far it takes. So let's say that this was like a meter stick or something that I've drawn right here. Meter stick. And then the wave traveled, I'll do a different color for the wave. The wave, like, let's say started in the center, then it went negative, then it went positive. Then let's say it did that again. That wouldn't matter. This is just the one wave. It went, started in the middle, went down, back through the middle, up, and then here, just like in harmonic motion. So if I were able to measure this and this were like 1 meter, that would be your wavelength. That's how much space it takes up, or how far it goes in one cycle. That'd be lambda. So it's like backslash with a little leg. Okay, so remember, it's like you're looking at it from above. So it'd be like you were kind of floating up here. Somebody's floating up here looking at what this wave looks like. So it probably, and by the way, let's say that this way is negative and this way is positive, just so we set our frame of reference. So your wave would probably look something like, if this is your center line, like that dotted line under here, your wave's going to probably look something like this if you were floating above it. So again, we can only see this part of it right here because the video, it only goes that far, but that's a half a wave. That's fine. We can figure out what the other one is. It would just be the same thing in the opposite direction. So I drew these lines on here so you can kind of see what happens with the wave. Now, for how far it travels, like backwards towards the angel statue, you kind of need to know how many people move. So let me show you how I did that. So it starts like she's starting right here. So watch what happens when she moves. So let's kind of count the people. Okay, so she moves. We got 1, 2, 3, 4, 5, and then that last lady, you can kind of see her hair, 6. I got 6. To me, it looked like 6 moves. So this would be right here. It's like first person, so you'd have like 1, 2, 3, 4, 5, 6. And so presumably there would be 6 more people on the other way. So that my guess is there are 12 people back. So it's like she's the first one and there's 12 more, or there's 11 more between her and the statue. So I kind of made some estimates in a model here. So I did this. This is one person. And I estimated that, see, and then 6 people. So I assumed that this is 6 people back. And then I kind of just I looked up and it's like the diameter of a human head's like between like 17 and 20 centimeters or, and then I just kind of like lined up and kind of thought about times I've done things like this. And I estimated that the dancers are about 2 feet apart. That's about 60 centimeters. So like 2 floor tiles in the school. So this is what that would look like. So if they're all like 60 centimeters apart, that would be 60 plus 60 plus 60 plus 60. That's basically 60 centimeters times 6, which will give you 360 centimeters. And then it's like money. If you had 360 pennies, you'd end up with 3.6 meters. So half of a wavelength is 3.6 meters. Now, of course, there's the other part of the wavelength. So that would be the same thing. 6 more dancers that are that far apart. So it's another 360 meters. So what you end up with is 360 plus 360 is 3.6 plus 3.6 is 7.2 meters. So that means lambda, your wavelength, is 7.2 meters. So that would be the answer to 2A for us. Okay, so this is what you should have on your paper for that. Write your assumptions. So assume 1/2 of the wavelength is 6 dancers. Okay, dancer spacing is about 2 feet, 60 centimeters. So therefore, half of your wavelength, lambda, is 360 centimeters. Therefore, your wavelength, which would be 2 halves, is 720 centimeters, and that's 7.2 meters.